Welcome to our next phase of Algebra for Success. Today, we're delving into the intriguing realm of factoring. Factoring polynomials is akin to unraveling the secrets within algebraic expressions. It's an essential skill that allows us to break down complex equations into simpler, manageable parts. Let's embark on this fascinating journey of factoring polynomials. Factoring polynomials involves breaking down algebraic expressions into their constituent parts, unveiling the hidden structure within. These expressions can represent a wide range of mathematical models, from quadratic equations to higher-degree polynomials. Let's start with understanding the basics of factoring. A polynomial is an expression containing variables and coefficients. The process of factoring involves finding the expressions that multiply together to produce the original polynomial. To begin the journey of factoring, let's explore some fundamental techniques that aid in breaking down these polynomials. Step 1. Greatest common factor, or GCF. Look for the greatest common factor among all the terms of the polynomial. This factor is the largest expression that divides evenly into all terms. For instance, let's consider the polynomial 6x squared plus 9x. The greatest common factor here is 3x. By factoring out this common factor, we get 3x times the quantity 2x plus 3. Step 2. Factoring by grouping. When you have four terms in a polynomial, try grouping them in pairs. Look for common factors in each pair and factor them out. Consider the polynomial x cubed plus 2x squared plus x plus 2. By grouping the terms, we get the quantity x cubed plus 2x squared plus the quantity x plus 2. Factoring common terms from each pair yields x squared times the quantity x plus 2 plus 1 times the quantity x plus 2. Finally, we get the quantity x squared plus 1 times the quantity x plus 2. Step 3. Difference of squares. Recognize polynomials that are in the form of a squared minus b squared. These can be factored as the quantity a plus b times the quantity a minus b. If we have the polynomial x squared minus 4, we can express it as the quantity x plus 2 times the quantity x minus 2. Here, plus 2 and x, 2 are the factors resulting from the difference of squares. Step 4. Abbreviated multiplication formulas. Our next factoring technique involves the abbreviated multiplication formulas for a minus b squared and a plus b squared. These formulas are particularly helpful when you encounter polynomial expressions with squares of binomials. The formula for the quantity a minus b squared is a squared minus 2 times a times b plus b squared. This formula represents the square of the difference between two values a and b. The formula for the quantity a plus b squared is a squared plus 2 times a times b plus b squared. This formula, on the other hand, represents the square of the sum of a and b. To illustrate these formulas, let's consider an example. Suppose we have the polynomial x squared minus 10x plus 25. This expression resembles the formula for the quantity a minus b squared, where a is x and b is 5. We can apply the formula for the quantity a minus b squared to this polynomial. Using the formula a squared minus 2ab plus 2 squared, we substitute a with x and b with 5. X squared minus 2 times x times 5 plus 5 squared equals 2x squared minus 10 plus 25. As you can see, the polynomial is indeed equal to the quantity x minus 5 squared, which means we've successfully factored it. Now let's explore factoring using the quantity a plus b squared with another example. Consider the polynomial I squared plus 14a plus 49. This expression resembles the formula for the quantity a plus b squared, where a is I and b is 7. Applying the formula a squared plus 2ab plus 2 squared, we substitute a with I and b with 7. I squared plus 2 times I times 7 plus 7 squared equals I squared plus 14a plus 49. The polynomial indeed factors as the quantity I plus 7 squared. Tips for success. Tip 1. Practice patterns. Recognize common patterns in polynomials to factor more efficiently. Tip 2. Check your solution. Always multiply your factors to ensure they yield the original polynomial. Factoring polynomials is a key tool that simplifies equations and aids in solving problems across various fields, from physics to economics. It's a crucial skill that lays the groundwork for more advanced algebraic concepts. In our next segment, we'll delve deeper into quadratic equations, where your knowledge of factoring will further enhance your problem-solving abilities. Until then, keep practicing your factoring skills and unveil the hidden structure within algebraic expressions. Keep practicing, keep learning, and you'll be well on your way to acing your algebra class. See you in the next segment.